Alright, welcome to Logic Chapter 3, Section 4. And we're going to use the truth table now to test validity. The same thing applies. We're going to use, we can do these truth tables, and you'll find in your book, the way they'll write them is they'll put each premise on a different line. So in this case, it's P horseshoe Q, and then the second premise is P, and then there's a line signaling the conclusion. That line actually means therefore. And so this would be an argument that's if P then Q, P therefore Q. It's actually what we call modus ponens. And what we do is we then can put this into a table in which what we do is we separate each premise with just a slash and we leave that blank, the space below it. And if you're doing it by paper, just make sure to leave an extra little space and put a line. And then we put two lines to signal the conclusion, and that means therefore. And once again, we just simply take, like P, it's T, true, true, false, false, and make sure it's the same here. And then we do Q, and we do true, false, and we do this, which is true, false, true, false. And what we do is we then can, work it out where we then, when P is true and Q is true, it's true. When P is true and Q is false, it's false. True, true. Okay? I hope that makes sense there. And then what we do is, if you remember our definition, highlight each of these lines, because these are the ones we're going to have importance. And essentially what happens is, and cross out anything that we don't need, and essentially what we're going to do is when we get to the end, we're going to look for lines in which the conclusion is true, but the premises are false. Because a logically valid argument is an argument in which, if all the premises are true, the conclusion must be true. And so if we find a line in which the premises are true and the conclusion is false, then we would know we have a contradiction. So what we're going to look at is we're going to look at the premises, and if we find one in which both of them are true, like this one, if the conclusion were false, we would label this invalid, because we would find that it is possible for the premises to be true and the conclusion false. But, like this, wouldn't make any difference. One of the premises is false, one of them is true, it wouldn't make a difference. If both of them were false, it wouldn't make a difference. It only matters if we find a line in which, if both premises or all the premises are true and the conclusion is false, then we know it's invalid. Now, if you find a line in which the premises are true and the conclusion is true, doesn't matter. If you find a premise in, lines in which the premises are false and the conclusion is true, doesn't matter. The only thing that matters, the only thing you can prove is you can prove it's invalid. And the way you do it is you find a line in which if the premises are true, the conclusion is false. And if that happens, you circle those letters, that line, and you then label it invalid and put an arrow or something pointing, somehow highlighting that line. And you say, here we go, that's proving invalidity. And if you don't find any line like that, then you label it valid. And that's all it is. And you can find here, now I want you to read through this. They're going to give you things called modus ponens, which is an argument called, affirming the antecedent, which anytime the antecedent is true, the consequent will be true, and that's a valid form. The second type is a thing called modus tollens, and that's whenever the consequent is false, the antecedent will be false. And so this is another valid form, and you can do that with a truth table and prove that. You can come up here, though, and you can come to something which is a fallacy called affirming the consequent, or something like that. Well, yeah, it's called affirming the consequent, and it's a form of a fallacy. And what happens is you do this truth table, however, and you do find a row in which this premise is true, this premise is true, but the conclusion is false. And so what you would do is you would come along and you would highlight that different color so that we would know that this line here proves that it's invalid. You would highlight it and you would label it invalid. And that's all there is to it. You just do that all the way down. There's another one called denying the antecedent, and Just because the antecedent isn't true doesn't mean the consequent doesn't have to be true. And that's basically the way it works. And these can get more and more complex. In this case, we have a argument that has, how many lines is that? 16 it looks like. Because it's 1, 2, 3, 4 variables. And in this case, they haven't done it here, but as I said, always make sure to highlight this line and cross out the other lines, because it will make it easier to follow. In this case, I'm not sure why they have a double line there, because that's not really important. Okay? And so read through these, because I also want you to remember what the words like destructive dilemma, because those are ones you can get. Destructive dilemma and constructive dilemma are both where you deny both consequences and one of the premises or one of the antecedents are false. Okay? And that's basically how it works. I'm not going to show you any examples. It's just truth tables and looking for the premises being true and the conclusion false. If you don't find premises true and conclusion false, then you have not proven it anything. You've just proven it valid. Okay?